Hello, my kiddos and kiddas. It is Miss Lloyd, and we are looking at the sum and difference formulas for our trigonometric functions. So here you can see all of the formulas for sum and difference when it comes to sine, cosine, and tangent. These are ones I'm going to be using with my students, and it's also ones that I don't force them to memorize because I myself don't have them memorized, and I use them every year. So yeah, these are going to be on a formula sheet, so it may be helpful to pause this video, write down these formulas, just so that you have an idea of them and you have them off to the side for when I no longer have them on the screen. So here I did do a typo. This should be pi over 12 instead of pi over 2. So we're looking at trying to find the exact value for cosine of pi over 12. Pi over 12 isn't one of our nice, pretty unit circle angles. I do know that I could change pi over 12 to something else that does have a pretty location on the unit circle. And so when I think about my radians, the radians that are at least in my trig hand trick, my first quadrant, I'm looking at pi over 6, pi over 4, and pi over 3, and of course pi over 2. So I want to figure out, is there a way to change pi over 12 into a combination of those angles? And so what comes to my mind, and you may not have to do this exactly, if you come up with something else, it's totally fine. And you should end up with the same thing either way, as long as these two angles either add or subtract to get you your 12. So I came up with pi over 3 minus pi over 4. So pi over 3, if I put this into fours, is 4 pi over, if I put it into 12ths, is 4 pi over 12. Pi over 4 is 3 pi over 12. So subtracting those would give me that pi over 12. So that means that instead of cosine of pi over 12, I'm going to be looking at cosine of pi over 3 minus pi over 4, since those are the same thing. Which means I'm using, you can see the formula here, that cosine of u minus v. So then when I'm doing this, I'm looking at the cosine of pi over 3, the cosine of pi over 4, and the sine of pi over 3 and pi over 4, which are angles that I know in the unit circle. So in this case, my pi over 3 is my u, and my pi over 4 is the v. And I'm just plugging everything into the formula. From here, I want to replace cosine of pi over 3, with what I know it is, which is 1/2. Cosine pi over 4, I'm going to be replacing with square root 2 over 2. My sine of pi over 3, I'm going to replace with square root 3 over 2. And then my sine pi over 4, I'm going to replace with square root 2 over 2. And now I do some simplifying. So multiplying out my first, I've got square root 2 over 4. And then the second, I've got square root 6 over 4. Because these are both over 4, I could just make these into one fraction. And then this is unfortunately as far as I can go. So whenever we're doing these, they're not going to be the prettiest, but they're also not incredibly disgusting. And we're done. As long as we don't have square roots on the bottom, we're pretty okay. And the next one that I'm going to do here in the video, we're going to find the exact value of cosine u plus v, giving that sine of u is 12 over 3, and cosine of v is negative 3 over 5. If I'm going to use cosine of u plus v, that means I need the cosine of both u and v, and the sine of both u and v. Right now I only have the sine of u, not the cosine of u, which means I'm going to have to draw out this triangle. If I know the sine, then that means that I know the opposite over the hypotenuse. If I have the cosine of v, which is going to be a completely different angle, that means I have the adjacent over the hypotenuse. So I'm going to be using these to figure out the entire triangles of u and v so that I can figure out both the sine and the cosine of them. I'm going to do this in a little bit quick manner, and hopefully you can follow along. If you have any questions, you can always post a comment down below and I can help you out. So for this first one, when we're going through u, it does tell me that I'm in between 0 and pi over 2, which means I'm in the first quadrant when I'm looking at angle u. So I'm going to draw this triangle in the first quadrant. It also tells me that my opposite is 12 and my hypotenuse is 13. So I know that those two legs are going to be very similar to each other, and that's going to make the x really short. This doesn't have to look exactly like this in order for you to figure out what that x value is. It doesn't have to be to scale at all. But from here, I am working with a right triangle, so I'm going to use the Pythagorean theorem to figure out what x is. And here, when I take the square root of 25, technically I have plus minus 5. I know that I'm going to be using positive 5 because we're in the first quadrant, and x is positive in the first quadrant. So that means my cosine of this angle u is going to be the adjacent over the hypotenuse, or 5 over 13. Now I'm going to do the same thing for v. So v, they tell me, is between, and I did a typo here too, pi over 2 and pi. So that means if it's between pi over 2 and pi, then it's going to be in the second quadrant. If you feel up to it, you can totally pause this video and draw out to figure out what your missing leg is going to be for angle V, and then compare with what I get. And so I found my sine of V to be 4 over 5. So my opposite over my hypotenuse for angle V. So now when it comes to my cosine of u plus V, I'm going to use a formula that I had said above for the cosine of u plus V. And then I'm going to go through and replace everything with what I know it is. So my cosine of u I had found earlier to be 5 over 13. Cosine of v was something that was given at negative 3 over 5. My sine of u was given with 12 over 13. And then sine of v I just found with 4 over 5. And then I do some simplifying. And now I've completed. This is as far as I can simplify with this fraction. So then that's how I know that I'm finished. The last one that I'm going to go over in this video, we are writing each expression as a trigonometric function of only theta. So noticing what's inside subtracting with theta is our 3 pi over 2, which is something that is on the unit circle and something that we know the sine of and the cosine of. So because this is one thing minus another inside of sine, I'm going to be using my difference formula for sine. And this is now going to represent my u, and theta will represent my v. And I'm just going to use that formula. Hopefully you already have it written down like I asked you to have earlier. So now here I can go through and plug in what I know about sine of 3 pi over 2. And 3 pi over 2 is on our y-axis, where we would have the point 0 comma negative 1, which means my sine value in this case would be negative 1. And my cosine, which is our x value, would be 0. Since it's on the y-axis, our x value will be 0. And then now doing my multiplication, I have negative cosine of theta. And 0 times anything is going to give us 0, so this minus sine theta times 0 just cancels out. And I have my final solution. I hope you found this helpful. If you did, please like and subscribe. Also, if you know of someone who this could be helpful for, please feel free to share. Spread the love.